Okay, I'm now going to do some more rationalising and show you why it's useful when you need to do fractions, but also we're going to do some rationalising by a thing called the conjugate. So let's have a look here at question 10. So in question 10, it says, make it rational and then find a common denominator. So here's 10c, and I've got 3 on root 7 minus 2 on root 3. Now you can see I've left a big gap because I need to rationalise both these fractions so I can get a common denominator. So when I rationalise, I look at the bottom and I go, well, that's root 7, and I'll get root 7 there. And when I rationalise this one, I'm going to go root 3 and root 3. Okay, let's deal with the first fraction. That gives me 3 root 7. Root 7 times root 7 is 7. Over here, I get 2 root 3 on 3. So now I have a fraction. Now to subtract these fractions, I must get a common denominator. And the common denominator I need, well, I'm going to multiply this one by 3, top and bottom. I'm going to multiply this one by 7, top and bottom. And that'll give me a denominator of 21. So here, 3 times 3 is 9 root 7 on 21, minus 2 times 7 is 14, and I've got my root 3 over 21. And then I just finish that up, make it all one fraction over 21. And that's 10c. Let's have a go at another one from 10. And I'll go straight to 10i. So I've got 5 root 2 on 3 root 5 minus, notice how I've left a gap, 4 root 7 on 3 root 6. Now I just have to rationalise the denominator. So I'm just looking at this one here, the first one. I'm just going to multiply top and bottom by root 5. And then this other one, I'm looking at the denominator, I'm going to multiply by root 6. Okay, let's do the first one. The top, the numerator, 5 times root 2 times root 5, that's 5 root 10. But on the bottom, I get 3 times 5 root 5 root 5. And I'm going to write that as 3 times 5. You'll see why in a minute. Now, the second one. 4, I'm doing the numerator first. Root 7 times root 6 is root 42. And on the denominator, I get 3 times 6, or root 6 times root 6, I get 3 times 6. And again, I'm going to leave that because I want to try and make these fractions as simple as possible before I make a common denominator. And I can see that 5 goes into 5. So this fraction is root 10 on 3. Over here, I can see that 2 goes into 6 3 times, and 2 goes into 4 twice. So it gives me 2 root 42 on 9. Now the common denominator, well, it's very easy now because I've got 3 and 9, and I know all I have to do is multiply the first fraction by 3, top and bottom, and I will get the common denominator. I'll get 3 root 10 on 9 minus 2 root 42 on 9, write them as a single fraction, 3 root 10 minus 2 root 42 all over 9. And that one was 3 root 10 minus 2 root 42 on 9. Am I right?
Yes!
Thank you very much. Now don't try and cancel that 3 and 9. You can't, because there's a minus in the operator of the numerator. You can't cancel. Okay. Now for the really hard stuff. So we're going to use this law, which they illustrate to us in question 13. And it's a law that we've already used. It's called the difference of two squares. So A plus B, A minus B, gives us the difference of two squares. It gives us A squared minus B squared. So how does that help us? Well, over here, they're telling us to show the difference of two squares. And then they ask you a question, well, how could you get rid of that thing in the denominator? Well, if you multiply the denominator by the number that will give the difference of two squares, or the thing that will give the difference of two squares, you should get it. So let's have a look. In 13b, it says, what would you do to get this? Now, if I multiply by root 2, well, I'll get 4 root 2, and that won't get rid of the surd. But if I use the rule above, and I can find the thing that will give me this, well, I've got a minus, so the thing that will give it to me is the same thing, but with a different sign, the plus. If I multiply by 4 plus root 2, now on the top, you've got to remember that this is grouped, so I've got 3 times that and 3 times that. 3 4s are 12, and 3 root 2. Now on the bottom, I've got the difference of two squares. 4 squared is 16, and 2 squared, root 2 squared is 2. And I've rationalised the denominator. 12 plus 3 root 2 on 14. And I checked that for question 13. And, well, it doesn't give me the answer for that. It does tell me what do I need to multiply by. Now, that thing that we are asked to multiply by, this thing here that we are asked to multiply by, is called the conjugate. And we multiply by the conjugate to get the difference of two squares, which will rationalise our denominator. So I'm going to have a go at 13D number 3. So 13D number 3. And then I'm going to do some more. So 13D number 3, I've got root 2 on root 4 minus root 3. First thing, what is the conjugate? What am I going to need to multiply by? Well, the conjugate is the same thing in the denominator. That's terrible. Same thing in the denominator, but with a different sign. And we do the same to the top. Now, watch what happens. Now remember, it's root 2 times that and root 2 times that. So on the numerator, I get root. Why have I got root 4? Root 4 is just 2. I'll leave it there. I get root 2 times root 4 plus root 2 times root 3. Oh no, I'll leave it like that. Root 2 times root 3. And I'll get root 4 squared, that's 4, minus root 3 squared, well that's 3. On the top, well root 4 is 2, so I get 2 root 2. Here I'll get root 6. And on the bottom I'll get 1. So that's just 2 root 2 plus root 6. And look at that. We've rationalised it even though it turns out it was just over 1 anyway. That was a bit silly. I don't know why they gave us one that had root 4 in it. I want to go down and have a go at some of the number ones in 14. So I'll do E, J, and O. So here's E. 3 on 1 minus root 3. Well, what do I multiply by? The conjugate is the same thing with a different sign. Well, that's easy now. 3 times 1 and 3 times root 3 gives me 3 plus 3 root 3. And on the bottom I've got the difference of 2 squares, so it's 1 squared, 1, minus root 3 squared, 3. So I get 3 plus 3 root 3 on negative 2. Now where does that negative belong? Well, wherever you want to put it. But if you put it out the front, make sure it's level with the vinculum and not seen to be up top or underneath. I like to put it up top. You can put a bracket in front of them. In 14E, Margaret puts it all in the top, which changes the sign of everything. Not Margaret, the book, the back of the book does that. Okay, I'm going to do J, 6 on root 2 plus root 5. J, 6, was it 6? On root 2 plus root 5. I'm going to multiply by the conjugate. Now remember, the conjugate is the same thing with a different sign, because that's what gives us the difference of 2 squares. Here we go. Now remember, that's grouped, so I get 6 of those and 6 of those. So 6 root 2 minus 6 root 5. Now on the bottom I get the difference of 2 squares. So root 2 squared is 2, root 5 squared is 5. So it's 6 root 2 minus 6 root 5 all over negative 3. I'd probably leave it like that, but I do like to have it out the front, but you have to be very careful that it is distinct from everything else. I'll probably put brackets there. In the back of the book in J, is it J or I? Oh, we can cancel. All right, this gets a little bit trickier. So here we go. I'm actually going to get rid of that bracket. And I'll put that negative back. Okay. I'm going to factorise the top. I'll take 3 out. It gives me 2 root 2 minus 2 root 5. I've got minus 3 on the bottom. The 3 will go. Now I get a minus out the front of 2 root 2 minus 2 root 5. Well, that minus will make that minus 2 root 2. Sort of like multiplying by there and multiplying by there. And that'll give me plus 2 root 5. And if I wanted to be really particular, I'd rewrite that because those two things are added and it doesn't matter which way I add them. So I get 2 root 5 plus negative 2 root 2, which is the same as 2 root 5 minus 2 root 2. Well, that one was a bit tricky, and that's the right answer. J. Okay, one more. You really need to work on these. You need to take your time. 2 root 5 on root 5 plus 2. So O, 2 root 5 on root 5 plus 2. First thing, I'm going to multiply by the conjugate. Well, that's just the same thing. Root 5 minus 2, root 5 minus 2. Remember, this is grouped, so it's 2 root 5 of those and 2 root 5s of those. So I'll write it out longhand, even though I wouldn't do it normally. And here I just get minus 2 root 5 times 2. On the bottom, I'm not going to write it out longhand, it's a difference of 2 squares. So I get root 5 squared, which is 5, 2 squared, which is 4. That's going to work out really neatly. So root 5 times root 5 is 5, 2 times 5 is 10. 2 times 2 is 4, and root 5. And on the bottom, we get 5 minus 4, which is 1. And isn't that nice and neat? 10 minus 4 root 5. And I think I am right. Is that correct?
Yes.
So, you need to practice these. You need to do lots. And the more you do, the better you'll get, and the more able you'll be able to produce the same thing in your exam. So good luck, and you have to do lots.